Today we are going to speak about differentiations. Differentiation of any functions. It may be algebraic functions, it may be trigonometric functions, it may be exponential functions, it may be any functions. Any functions is differentiable. Now, how to differentiate algebraic functions? First, I will speak about. Now, we have some certain rules for differentiations. Differentiations of product functions, differentiation of product rule we have, differentiation of u by v rule we have. So, first, differentiation of product rule. Product rule of differentiation. Let's take an example. With example, I will explain you with formulas also. Say, let's take u equals to f of x, v equals to g of x. Now, u is function of x as well as v is function of x, another function of x. So now, if I want to differentiate differentiation is notation by d by dx of f of x into g of x. This is called product rule of differentiations. So let's take this is the first function. Let's consider fx is the first function, gx is the second function. Now, keep f of x as it is, differentiate gx, after that d by dx of gx. Since these differentiations gets over, keeping as it is, and differentiate the rest one, d by dx of f of x. Now, for differentiation product rule, you can choose any functions as you wish. Means it's commutative. Commutative means commutative over multiplication. It means a into b is equals to b into a. Example, 2 into 3 is same as 3 into 2. It means this implies 6 equals to 6. So, in the product rule of differentiation, you can choose any function as a first function. If you change over here, if you change g of x, f of x, dy dx will be what? Gx. I am keeping first function as it is, then differentiate of second function f of x. Since this function differentiation is getting over, keep as it is and differentiate the last one, which is not differentiating already. So this value or answer will be same as this value. So in differentiation of product rule, if you change the functions, flip either first one, second or first one, the values will be same, one and same. So let's try an example. Let's try an example of, say, example number 1, differentiate dy dx of, say, x into sin x. Now, let's consider x as a first function, sin x as a second function. Now, applying this formula, either one, this one and same, this one, this also same, you will get same answer, this also will get same answer. So, over here, let's apply fx as x, gx as sin x. Now, x keeping as it is, differentiate sin x, d by dx of sin x. Since this differentiation is getting over, sin x differentiation is getting over, and plus with plus sign sin x and d by dx of x. We know that x differentiation of sin x is what? Cos x plus sin x. Differentiation of d by dx of x is what? 1. Therefore, x into cos x plus sin x is the answer. Now, if we change this, let's say if we change d by dx, or if you change sin of x into x. The answer will be same. Let's see. Let's check out over here. So first function is sin x, second function is x, sine of x, okay, and then what? dy dx of x. Since this differentiation is x, differentiation is getting over with plus sign, keep as it is x, again dy dx of sin x. Now we have sine of x, dy dx of x is 1 and differentiation of sin x is cos x. So dy dx of x is what? 1 plus x into dy dx of sin x is cos x. Therefore sin x plus x into cos x. So this answer is same as this answer. So in the product rule of differentiation, if you choose any functions, either fx is first function or gx is first function, the answer is one and same. This is for product rule.